Hello!
Hello and welcome back to another Fun Fact Friday.
When you're pregnant, one of the many things you'll hear in repetition is to keep up your folic acid. It's important to prevent neural tube defects. But what they don't tell you is that it's not folic acid that prevents them, but folate.
The other thing that often gets unsaid is in relation to a particular gene mutation. Its acronym looks like a really rude word, so we'll repeatedly mention it. And if you have this gene mutation, by taking folic acid, you could effectively be causing the very thing you're trying to combat, folate deficiency.
Fun Fact Friday, week 126.
Folic acid could cause birth defects.
Grab a cuppa and get settled in. We are diving deep into this week's fact.
Folate, which is also known as vitamin B9, is essential in the formation of DNA in every cell of the body, allowing each cell to replicate perfectly. And in addition to another B vitamin, B12, it's also responsible for nerve function and the formation of red blood cells.
Folate is also super important when you are pregnant, and insufficient levels are known to cause neural tube defects in developing babies, and is why many health professionals recommend that you supplement with folic acid.
However, to metabolize folic acid, we need genes called methylene tetrahydrofolate reductase genes, or MTHFR genes. And it's because of the look of this gene's acronym that we will henceforth refer to them as motherfucker genes.
There are currently 34 known motherfucker genes, but research to date has focused on just 2 of these. The ones in positions C677T and A12898C. A mutation in these genes has health implications, most notably during pregnancy.
So you may be asking, what is a neural tube and what happens if it gets a defect?
We all had a neural tube, and it is the basis, or should I say was the basis, for what later became your brain and spinal column, your central nervous system.
Your neural tube started out as a neural fold at about 3 weeks into pregnancy. And a week later, this fold began to fuse along its length to create the neural tube.
A neural tube defect, or NTD, is when this fusing fails to fully complete. A baby's spine or skull doesn't form properly, or the spinal cord or part of the brain develops outside the body.
The 2 most common types of NTDs are anencephaly and spina bifida. Anencephaly is when a major portion of the brain and skull are missing. This occurs because the rostral, or the head end of the neural tube, doesn't close. Spina bifida means split spine, and the lack of neural tube closure occurs in the spine, the effects of which can vary in seriousness.
Folic acid supplementation has been shown to drastically reduce the incidences of NTDs. As a result of these findings, 81 countries since 1998 have introduced mandatory folic acid fortification of cereals.
Now, we're not talking breakfast cereals here, we're talking any processed grain used in food, and it should be noted that the UK did not adopt compulsory fortification, although it is currently under pressure to do so. There are arguments both for and against mandatory fortification.
One argument for fortifying foods is to prevent NTDs, because the time when folate levels are most critical is a time when the vast majority of women are unaware that they are even pregnant. Remember, the neural tube closes at just 4 weeks into a pregnancy.
In an average week in the UK, there are 2 babies born that are affected by NTDs, and 14 terminated pregnancies because of them. It's argued that compulsory fortification could therefore reduce these instances, because high levels of folic acid would more likely be in a mother's system when she needs it.
Whereas one argument against mandatory fortification is the subject of today's fact. But to understand it, we need to dive even deeper.
There are key differences between folic acid and folate. They are both types of the water-soluble B9 vitamin, however that's where the similarity ends.
Folate refers to a family of compounds that are found in leafy greens, legumes, and many other fruits and vegetables. The name folate derives its meaning from the Latin term folium, meaning foliage. Folic acid is an inactive folate and can only be found in very small amounts naturally in food.
However, it is most commonly consumed in its synthetic version and is used to fortify foods such as wheat flour and breakfast cereals. The big difference between the two happens when they're metabolised, and more specifically when they're metabolised into the active form of folate, called L-methylfolate or 5-MTHF. It's in this active form that folate gets transported into cells, where it can even cross the blood-brain barrier.
Folic acid is inactive and has to be metabolised or converted by our bodies through 4 separate stages to be transformed into its active form that our body can use. These conversions require enzymes as well as other genes for these processes to work.
Folic acid has to first be converted to dihydrofolate or DHF.
DHF then has to be converted to tetrahydrofolate or THF.
These first two conversions come under the responsibility of the DHFR gene, although the first process is slower than the second.
THF then needs to be converted to 5,10-methylene tetrahydrofolate under the care of the SHMT gene.
5,10-methylene tetrahydrofolate then needs to be converted into the active form that our body can use, L-methylfolate. The gene responsible for this conversion is the MTHFR gene, and we like to call it the motherfucker gene. So in short, for the body to use any folic acid found in food, it must go through these changes. Folic acid to DHF, DHF to THF, THF to 5,10-methylene tetrahydrofolate, and 5,10-methylene tetrahydrofolate to the active form of folate, L-methylfolate. Folate, however, can either start at the same place as folic acid and go through those 4 processes, or, and this is the kicker, skip the entire process completely. Much of the dietary folate we consume is already in this active form, L-methylfolate, and can be used as is without any other processes or conversions needed.
Bonus fact! The first conversion from folic acid to DHF is a slow process. The reason is that folic acid was not found in any great quantities before its synthesis in 1945, and the process of converting folic acid into something useful became co-opted by the DHFR gene. The DHFR gene was originally responsible only for the second conversion from DHF to THF, and is far quicker in doing so because that was its original purpose. And here is where the motherfucker gene becomes a motherfucker. As you may have noticed, the motherfucker gene must be working correctly to process the last step of the conversion process of folic acid into its useful form.
If the motherfucker gene is not working correctly, i.e. it's mutated, then this process becomes compromised and does not work to its full potential, if at all. Folic acid supplementation is mostly ineffective at combating folate deficiencies in those with a motherfucker mutation.
As a result, the motherfucker gene mutation can be linked to anemia because of the importance of folate in conjunction with vitamin B12 in producing red blood cells. But most notably, it could be the cause of those having trouble getting pregnant or suffering multiple miscarriages.
As if that's not enough, it gets worse. Because those that have the motherfucker gene mutation cannot properly process folic acid, it's thought that it can build up in the body and can become attached to folate receptors. When it's attached to the folate receptors, it effectively blocks them from receiving the active form of folate.
So by taking folic acid when you have the motherfucker mutation, you could be effectively blocking your ability to take in the active form of folate too. This could exacerbate and potentially cause folate deficiencies where none may have existed before adding folic acid.
Reports vary as to the number of people that have motherfucker mutations. Some have reported it could be as high as 1 in every 6 people.
We're only just starting to learn the full extent to which this can affect other processes and what additional issues the motherfucker gene mutation may cause. Folate levels are critical to a developing baby, and we do not suggest that you avoid folic acid if you are pregnant or trying to get pregnant.
However, if you suspect that you do have the motherfucker gene mutation, then you could look for a genetic testing service that checks for mutations in the MTHFR genes, and you should also consult with your healthcare professional.
For those of you that would be keen to stick to folate as much as possible, then there are supplements, including pregnancy and conception supplements, that state they have the active form of folate, L-methylfolate, or 5-MTHF. And of course, there are also plenty of foods that rank high in folate, such as all types of dark leafy greens and cruciferous vegetables, asparagus, oranges, grapefruit, strawberries, beans, peas, lentils, avocados, and many more besides.
Whether you have the motherfucker mutation or not, eating well should be part of your strategy for being healthy. So eat your greens, because we all want to be healthy motherfuckers. Thank you for joining us for another Fun Fact Friday.
We would love to hear from you, so please like, comment and share to show you care.
And we'll see you next week.